In this video, we're going to introduce you to a new data type. We're going to take a look at enumerations. Now, enumerations are going to look a bit different than the data types you've been working with up until now. Up until now, you've been dealing with, for the most part, predefined data types. I can come in here and I can say, give me an integer, and make that integer name called I, and we're ready to go with the integer I. It's as simple as that. An enumeration, on the other hand, is a data type that we have to go in there and define. We don't have to define an int. An int32 is already defined for us in the C# language. We just use it. But an enumeration is a special data type that we have to go in there ahead of time and tell the compiler this is what our particular enumeration that we're creating at this moment looks like before we can actually start using it. All right? Might sound confusing. Don't worry. It's going to make a lot of sense in just a minute. The first thing you need to understand, though, is why do we want to have an enumeration? Why enumerations? Simple. It is a way for us to group related constants. Let's take just a minute and think back to Volume 1 in the XNA Xtreme series to the game Cannon. We made heavy use of constants, didn't we, Logan?
Right. There was several properties that we had to store, and we stored those in constants.
That's right. And when you say properties, you're talking, though, about numbers that did not change throughout the entire life of the application.
Right. Properties of the game, kind of like settings for the game almost.
Like we had a screen size, a width and a height, and we didn't want the width and the height to change as the program was running. That'd be kind of odd, wouldn't it? We set it to 800 by 600, and you stay at 800 by 600. So if I was to come in here and say const, C-O-N-S-T, int, I, or let me do this, speed, that makes more sense, equals 5, speed will always be 5. We can always rely on that. And then when we're coding and we say, you know, the enemy's whatever is equal to, and we can just say speed. It's so much easier when we go back and read through the code to see the word speed instead of the literal 5, because if I was reading somebody else's code and I just saw a 5 plugged in the code, I'm not going to know what that means necessarily. But to see the word speed, that deals with, well, a speed of some sort. So that is going to kind of clue me in on what's going on, right, Logan?
Also, it means you don't have to bury literal values throughout the code. You have labeled values that are easy to change because you will very often put that constant at the top of the whatever you're writing.
You got it.
And it makes it a lot easier to find, a lot easier to maintain.
But yeah, if I came back to you and said, you know, 5 was cool and all, but it was a tad bit slow, Logan, I want you to change speed. And let's say that you had hard-coded speed all throughout the application.
Right, you could even have multiple places where speed might be hard-coded.
That would be horrible, where instead I can go, okay, try the game now and tell me what you think. Ready to go. Well, this is a constant, but check this out. What if I needed to have a couple of constants that were related? Now, I'm going to pick on a bool for just a minute because it kind of looks like an enumeration, but we could, in a sense, almost define our own if we want to real quick. A bool doesn't contain a numeric value. It contains the word true and the word false, right? Well, an enumeration allows us to contain grouped words, if you will. Take a look at this. So we have true and false. If I was able to somehow come in here and say, look, you know, I want true to always be equal to 0, false to always be able to be known as 1, and I want to just kind of package all of this stuff up somehow, and we're going to call it our bool. Now I'd like to be able to define our bool somewhere else. This is our own data type. And then if I was to set it to true, I know that I can rely on it to have a value of 0, and if I set it to false, I can rely on it to have a value of 1. Now, again, I'm just picking on bool right now. Bool is its own true data type, right, Logan?
Right, it's different than an enum, but it just makes a good example of saying, like, well, what if you wanted your own data type that had words like true and false? You could do a mock-up scenario with an enum.
Precisely. So we are indeed grouping, that's why I drew this interesting little mushroom cloud around it, we are grouping two related constants together. Why am I calling them constants? Well, they are. I want true to remain 0 throughout the application's life, and I want false to remain 1 throughout the application's life, right?
Right. As a matter of fact, if you could change the values, that would destroy the integrity of the enum.
There you go.
You couldn't rely on those labels to be the proper value.
So that is the key thing I wanted you to understand before we start showing you syntax and actually typing out some real examples. I wanted you to understand that an enumeration is nothing more than a group of related constants. And here we've demonstrated with true and false. They are related because in this particular case we're dealing with yes or no type situation. Okay? So let's go ahead and clear this off and start out by first introducing you to the basic syntax of enums. So to create an enumeration, we have an optional modifiers, and then we start off with the keyword enum, followed by the name, the identifier, followed by another optional piece of information. So it's a colon, base type. Looks scary, but we will be talking about this in just a minute. You're going to be like, oh, that's so easy. And then from here, I'm going to actually drop down. Instead of putting this all in one line, I don't want to confuse anybody. Though, of course, this all could go in one line. We all know that. But dropping down here, then at this point, we come in here and we create our enumeration list. So this right here is our enumeration list. Kind of lies at the heart of the whole thing. So how we had true and false just a minute ago, we would see true and then false, just like such. And we have a comma separating all of them except for the last one. And if you want to get real fancy with syntax, you have an optional terminator that you can put at the end, but you don't have to. Okay, so this is the basic syntax. Let's go ahead and start off with modifiers. We've seen modifiers. If we created this type definition, because that is what this is. This whole thing right here is a definition of a type. So I'll put of a right here just because it reads funny if you don't. So it's a definition of a type. This is going to tell the compiler that this identifier, whatever it may be called, a minute ago with the example I gave, it was what? My bool. So we'd put my bool as the identifier, but we're telling the compiler that, hey, we're about to create our own data type. It's called my bool, and it's going to contain the following two constants. That's what we're grouping together. And the compiler's going to be like, okay, cool. I now understand what it is, and you can now declare it and use it. So that's the whole idea here. So now that you've seen the basic syntax, there's no better way to make this thing clear than to give you an example of it in action. So let's pick on something that everybody should be familiar with. Browsers. Everybody uses some sort of browser to browse the internet. I know that all of you guys that are in the XNA Xtreme classroom are using browsers because you have to go into the classroom to communicate with one another. Now, since we all know what a browser is, we know that there are different flavors of browsers. We have the Internet Explorer, we have Firefox, we have Opera, and the list does indeed go on and on. But those are like three of the top ones. So in this particular case, what I want to do is I want to have them grouped together and looked at as constants. IE will always be IE. Period. It's not going to morph throughout its existence. Firefox will be Firefox. Well, okay. Maybe in the real world it will, but inside our application, IE will always be IE. You get the idea. I saw that little twinkle in Logan's eye. So let me draw a line right here. And come over here and draw out a very simple example. So we'll start out using the syntax above. Now, modifiers, I don't need to come in here and do public or private, because I'm giving you a very basic example. That's what modifiers means. Actually, Logan, I think I just jumped ahead of myself a second ago because I started to tell him about modifiers, and I got all carried away with enum itself. But yeah, that's what modifiers are. We've seen that, like I said, public, private, static, etc. But we're not going to worry about that at the moment. That really comes down to us controlling the scope of where this type definition can be seen at. But let's go ahead and get on back with the cool stuff, an example. So we'll start out with enum. And its identifier is going to be browser. And then I'm going to drop down to the next line. Notice I am not using this optional base type at the moment. It is optional. So I'm going to come down here. I'm going to do an open curly brace. And I'm going to simply do IE, comma. Then I'm going to do Firefox, comma. And then I'm going to do Opera. And then I'm going to close this off. There we go. This is a type definition. This is telling the compiler that we now have a type called browser. And browser basically contains three things. At the moment, it contains a 0, a 1, and a 2. Now that may really blow your mind. That's right. There are values associated here. i.e. Firefox Opera, look at that as our constant names. How a minute ago, remember when I showed you us making a constant speed? This is kind of like speed. It's the name, if you will. But there is a value associated with it. If you do not specify the value, and I have not specified the value here, then here's what happens. By default, this first one starts at 0. Then the next one becomes a 1. And the next one becomes a 2, so on and so forth, okay? The next thing you need to understand is that when working with enums, these grouped constants, they all do have a type. There is an underlying base type, and it is by default, without us specifying, an int. Okay? So these are all ints. It's like me saying int IE, int Firefox, int Opera. So now you know if I wanted to come into IE and instead of just letting it get a default 0, if I wanted to actually assign a number in there, how much room do I have to assign a number? Well, it's an int 32. So I have 32 bits that I can work with. Right, Logan?
Right.
Okay. So now that you see how that works, that kind of brings this back into scope. I can change the int to another type if I would like. An int, maybe I know that I only want to store the numbers 0, 1, and 2. Do I really want to take up 32 bits 3 different times? I may want to do something a lot smaller. Like I may want this to only be perhaps a byte. So I could come in here and say, look, we don't want to store that much information. Make the underlying type for this enum a byte. Now, by doing that, instead of using the default int, now all of these grouped constants are of type byte. All right. So now we cannot go in there and shove giant numbers into IE, Firefox, and Opera. But right now, with the way that we're using this enumeration, by the way we're defining it, we are not setting our own values in here. We are allowing the enumeration to handle the default assignment of start at 0 and then simply continue adding one number with each new constant that we add in. And this is really handy. If we needed to create something that, let's say later on we might have to come back in here and a new situation arose and we need to throw another browser in here. Well, now all we got to do is put a comma in and put the new browser. It's called the Buzz browser. That's all I have to do. It automatically gets its own type now, or its own number. So I don't have to do anything fancy other than just come in and add a new constant. It's just that simple. Now, of course, I can go in there and give these guys their own values, but we'll take a look at that in just a minute. What I'd like to do at this point is show you how we can use this, because at this point, this whole thing, like I said a few minutes ago, is what? It is a type definition. So now that we have told the compiler this is a new type that we're going to be dealing with, how can we use that type? Well, what I'm going to do is come over here, and let me pick a place to draw a line. So now down in a method somewhere, I want to use this, and I'm going to draw another line because I'm going to give you a nice little demo here. We know when we're down in a method and we want to create a variable, what do? Well, let's do an integer. We simply first put the data type down, so it's going to be an int, and then my int. We give it a name. This has declared a variable of type int, and it is called my int. If I wanted to create a browser variable now, it's quite simple. I do the exact same thing. I come in here and I say browser, Okay, so the casing, everything has to match. This has to match this, dead on. So this is our data type. Browser, now I just got to give it a name. So we can come in here and say my browser. And terminator. Look at this. Exact same idea. Data type, the name for the variable. Data type, the name for the variable. Easy as that. Now, down here, the next thing that we would do is we'd initialize our new myInt variable. So I could say myInt equals 6. Woohoo! We've now put 6 into the variable myInt. Well, how do we assign information into the variable myBrowser? Well, it's really easy, but it's different from what you've seen so far when working with predefined data types. So I can come in here and say my browser, because that is, at this point, that is our variable, equals, now check this out, browser dot, and let's say I'm using Firefox. There you go. Now, this is how you go about assigning data into an enum. Now, of course, there's a couple other ways we can go about this. We'll talk about that in a minute. But this is the standard way. So this puts Firefox, if you will, over into my browser. Logan, were you about to say something?
It's almost like it looks at the definition itself to see what can go in it.
That's right.
It's almost like you have to pull one of those things out of the definition and say, I want to store that one. And so that's what it actually puts in the myBrowser variable. And where that does differ a little bit from the integer example is in the integer, you can literally type 6. You have a 6 button on the keyboard.
That's right.
With your own custom defined data type, you don't have a button on the keyboard that represents it. You don't have a Firefox button. I was going to say you don't have an IE button, but then some of those crazy keyboards that do have an IE button.
Exactly.
So rest assured, that wouldn't be your browser IE
That's right.
value.
Okay, so with this being the case, if I was to turn around and over here simply say write out, now remember this, that stands for console.writeLine, blah, blah, blah. But if I was to say write out myInt, it would convert it to a string and write out to a console 6. Well, if I came over here and told it to write out my browser, then this is going to actually write out Firefox. Okay? So, Logan, let's take a look at this over inside of Visual Studio.
Okay. So let's jump over here, bring up Visual Studio, and I'm going to start a console project so that we can try some of this out.
Now first, where do we put this type definition? There's actually a couple of places we can put it. We can put it outside of the class. That means basically inside the namespace outside of all classes. So right here at the very top. Or we could put it inside the class itself. It really comes down to, scope. Where do you want it to be able to be seen at, used at, etc. So just the big thing here is to understand this. I cannot define an enumeration inside of a method. Okay, that we can't do. So Logan, let's go ahead and define it outside of class.
Okay. So I'll jump up a few lines, and then we can type out enum, and then the identifier, which will be browser. Then I'll jump down and we'll block this in. And inside of browser, we want to have things like IE. Now I'll put a comma. We want Firefox and Opera. All right. Looks good. And I'll do a quick build, make sure that everything is typed correctly.
Okay.
And there we go.
So now let's go ahead and jump down into the main method. And now let's go ahead and create a variable of type browser.
Okay. So that means we'll have browser.
Oh, back up a couple. There we go.
So we have a browser, and then we're going to call this my browser.
All right, now let's go and jump down to the next line and initialize it with some data.
So my browser equals
Look at
browser.
that, it jumps right down to browser.
So browser dot, what do you want to set this to?
Look at that, how convenient. It's already showing us what we have access to. What are our group constants here? So yeah, let's go ahead and set it to Firefox just to follow the example. All right, very cool. Now let's go ahead and do a console.writeLine. So
console write line, we'll write out my browser.
Okay.
And then I'll do a read line just to hold up so we can see what the output was. So read line. All right.
So once again, my browser should simply contain Firefox. Let's go ahead and execute it. Firefox. Beautiful stuff. Believe it or not, enumerations are very powerful. They provide some fantastic flexibility when needing to work with group constants. So go ahead and enter, Logan, and let's jump back. Now let's take a look at a few other things real quick. What if we wanted to see the actual value that was being inside there? As a matter of fact, let me go back to the whiteboard over here. If I wanted to perhaps, let me pull this down. Extract. Remember how I showed you that there is indeed numbers being stored in those constants, and I demonstrated it right here. What if I wanted to show you that? Because Firefox should be a 1 because it is the second thing, and it's 0 base. So the second entry makes it a 1. So if I wanted to extract that, let's say I wanted to create like an integer, and we'll use I as our example over here, equals, and now I've got my browser terminator. Well, this is an error because these are two different data types. So what do I need to do? You guys should know from the last video, I need to cast. And how do we cast? Well, I need to do an explicit cast. So I'm going to do the cast operator, int, like that. So this basically says, look, let's convert what is in my browser to an integer and stick it over into I. And then if we were to come in, ooh, I didn't put an E on that. And then if we were to come in here and do write, and write out I should print out a 1. Okay? So, Logan, let's go ahead and throw this in there real quick just to demonstrate.
Okay. Let's jump in, I guess, right before the write lines.
Okay.
So we could do something like int I is equal to...
Go ahead and just set it to browser before you cast. So int I equals my browser. And then let's show them the error.
Browser. All right, so we try to build...
Ooh, we cannot implicitly convert. That's right. So we need to explicitly. So let's go ahead and do just that. So the cast operator int, and now if we F6 it, it builds just fine. And now let's go ahead and jump down and do another write line under that write line. And let's go ahead and write out the contents of I, and let's go ahead and execute. So look at this, Firefox and 1, exactly like I said. Now go ahead and close that and check this out. This is where things get interesting. Let's go ahead and change where we assigned my browser, browser.firefox. Let's change it to Opera. Okay. Because now when Logan runs it, we should see Opera and the number 2. Opera and the number 2. This is working beautifully. All right, go ahead and close that. Now, the next thing I'd like to do is go ahead and demonstrate that we don't have to start off at 0. It's 0 based by default. But if we'd like, we could say, let's start this off at 5. So I could say, let me kind of clean this up just a little bit here, and we'll take some of our old notes out. I could start out with the exact same type definition and say IE equals 5, comma. That's the only thing I'm going to change. Now remember, the way this works, the next one is going to be equal to the value of the last one, plus 1. So the Firefox would be 6, Opera would be 7, and if Buzz, the ultimate browser, still existed, it would be 8. So Logan, let's demonstrate this real quick. Go ahead and jump back over into Visual Studio, and let's set IE equal to 5.
All right, IE equals 5. Everything else is left as it was.
Okay, and let's go ahead and so, again, IE is 5, Firefox would be 6, Opera would be 7. So if you run it, we should see Opera and 7 now. Ooh, Opera and 7. So we do have the ability to come in here and control this number ourselves. And then we can do all sorts of crazy stuff. This is where you got to be really careful. Go to Opera, put a comma, and put Buzz down next. Okay, so now how about put Opera equals Firefox.
Ooh.
Prepare yourself for pain. All right, so at this point, if we start out, well, just first of all, go ahead and build just to show them that this builds just fine. And now, let's see. So we're going to start out with IE equal to 5. Then we're going to set Firefox equal to 6, right? And then Opera is also going to be equal to 6. And then Buzz is going to be equal to, well, whatever comes after Opera, which was 6, which would be 7 then. So Opera, so 5, so we should have 6 and 6 for both of these. So we should see printed out Opera and 6. Let's go ahead and make sure. Look at that. Firefox and 6. This is even better. Yes, that's fantastic. Because what is Opera? Opera's Firefox now. I should have caught that when explaining. That's what happens when I get all excited and talking too fast. That's fantastic. Opera is Firefox. So that is what we're going to see. Actually, we could make it even more confusing because what is Buzz then equal to? Buzz is technically equal to Opera.
So that's where using the actual names when you're trying to write something out can actually end up being confusing. When it goes to try to resolve one of those names, it says, all right, well, Buzz is, well, equal to Opera because it's looking through value-wise. It's basically starting at the beginning and going through value by value. So that's why when you try to write out Opera...
Change it to Buzz now.
Because you've thrown the index off.
And Buzz, okay, well, it's still going to give us Buzz, but it does give us that 7.
I can see where that's going to, because Opera and Firefox have the same value in them.
That's right.
So it says, all right, let's see which one of those was 5. Firefox, there, that's 5. So we print out Firefox instead of Opera.
Right. I've gotten some really interesting things to show up by, let's just say, screwing with assignments like that. But I just wanted to point out that you can do it. Now, how often do I do this? Well, almost never when I start taking one value and have it referring to another value internally. That's pretty rare for me because this makes it a little confusing when you go back over and you start reading things, especially if you got a lot of enumerations in there and different ones are pointing to different things. Another thing, just to let you know that you can't do is you can't create a cyclic condition where I was to come in here and say Firefox is equal to Opera and Opera equals Firefox. The browser's going to go, I don't think so. And it'll stop you right there instead of trying to just make the whole world implode because that's just a bad thing. So anyways, I did want to take a second and point this out. Now with that being pointed out, let's go ahead and take a look at why you might want to go in here and have a group of constants but not have their values increment. Basically have different predefined values that you give each one, but they're not related whatsoever. And what I mean by not related, it's not like a consistent or a continuous 5, 6, 7, and not a sequential set of numbers.
And the only reason that's happening is because we're not specifying all of the values.
That's right.
It's taking where we had left off and then continuing to add on to that each time we make another constant.
You got it. So I'm going to jump back over here. Let's go ahead and bring up another sheet of paper. So we'll bring this up, hide this out, hide that. And I'm going to go ahead and scroll back up a little bit just to give myself some room. Actually, I'm going to give myself plenty of room because I might do all sorts of stuff here. We, Logan, have been charged with writing some software for a remote control. Cool, huh?
Yeah, certainly.
So here's how it works. Now, Company X, I don't know who they are. Company X, they were in charge of putting all the circuit logic together that worked with the buttons and all. But now we've got to go and give the actual code that's going to be loaded in and make it all work together and transmit information, okay? So basically we've got this remote control, and when you press buttons, our software is going to receive information in regards to an infrared code that needs to be transmitted out to the TV or the VCR or whatever it may be. So what we need to do is demonstrate how we can put these IR codes into an enumeration and use them. Sound good?
Right, because if we have, obviously these codes are going to be quite possibly cryptic, and there could be a lot of them, so we don't want to have to remember them number by number.
You got it. So let's start out with our type definition. And I'm going to call this IR code. And inside of IR code, let's start out with play. Alright, so this is for a DVD player. Sounds good to me. And 53 happens to be, for the particular model that we are creating this for, 53 is the IR code. Stop is going to be 16. Now, these are fictitious numbers, guys, so in case anyone's sitting out there watching this going, oh, where'd they get 16 from? We're just saying that the manufacturer told us that the IR code 16 is what needs to be transmitted to our DVD player in order to stop it from playing or continuing to play. Next is going to be rewind. And rewind, not rewing. That's kind of funny. So rewind is going to be a 12. and let's say fast forward, has a value of 13. So these guys come right after one another because of the way they're related. And then we will go ahead and close this off. And at this point, if you did not catch the error that I was throwing in there, I'm going to tell you to rewind and start watching again. I just wanted to see if anybody would catch this. I purposefully messed up the syntax. What did I do? Come on. Commas. You don't go in here and you put terminators at the end of these. Hopefully somebody was yelling at this thing as we were going through. You separate your different constants with a comma. And you do not have a comma at the last one. There we go. All right, so hopefully you guys caught that. Now, we've got our type definition in place. So let's just pretend that that is above our method. And at this point, all code that I'm about to write is going to exist inside our method. So Logan, I'm actually going to, this is going to be the start of main. I'm just going to indicate an opening curly brace because I'm going to create another method here. So this will just stipulate is main. So I'm going to start out by first declaring a variable of type IR code. And what are we going to store in here? Well, we are going to store a transmit code. Like as such. All right, now, I obviously am not going to code all of this out. So we're all just going to stipulate how certain parts of this is going to work, and I'm going to do this with comments. So we're going to say that there is a loop that happens right here. And inside this loop, so this is going to indicate inside, we're basically waiting for a button to be pressed and us to be handed some information. So get button press. So button press raw data. And then we're going to process that raw data into a IR code. We'll talk about how to do that in a minute. But let's just assign it right now. Okay? Here's what I mean by that. So we'll pretend that somebody just hit the play button. So we're going to kind of skip ahead and say transmit code. They hit the play button. So basically it is an IR code dot play. Terminator. Now what is getting stored inside of transmit code? A 53. It's IR code dot play, which is a value of 53. So we now have access to that 53. That's what I'm getting at here. So now at this point we've got the code, so we could come over here and say, all right, well we have another routine that handles the actual transmission of it. So we could say that routine is called transmit. The only reason I'm throwing this in here because I want to demonstrate actually sending an enumeration type over to another method. So transmit, and we're simply going to send it transmit code, like such. And then, of course, this is kind of like the end of the loop. And I'm just going to throw a console.readline right here just to hold up execution. And that will be all of our main method. So, real quick, let's go ahead and create this other method. So, since we're just going to stay within the class here, we'll have a static void transmit. And this is the reason I'm doing this. I want to demonstrate us actually passing an enumeration type over to a method. So what is it going to accept? Well, it's going to accept one parameter in of type IR code. And what do you want to call it? No, I'm going to call the parameter name code, because that's all we need. It's just a code at this point. And then so inside here, Logan, what I'm going to have you do is write out two things. I want you to write out that we are something along the lines of transmission action. and then we're just going to print out the code itself, which means it should have, in this particular case, it's just going to have play. So it's going to say transmission action, play. And of course, you got to have the colon in there. And then we're going to, on the next line, we're going to write out, just to demonstrate that we have access to both these pieces of information, we're going to say transmitting IR code, colon, plus, and now I want to actually see that information, and once again, we have to cast it to get the value out of it, and since up here we did not change the underlying base type by putting, remember, the colon and a new type up there, since we didn't do that, then it is an integer, so I'm just going to simply come over here, I'm going to tell it to cast to an integer code. And then there you go. I was about to throw a terminator in. This is not a valid line. And then that will end off this guy right here. All right? So with that, let's go ahead and spend just a second and talk about this. And I'm going to do another one of these tricks here. Let's go ahead and come up here and grab myself another color that I can use. So we come through here. The first thing the compiler is going to do is it's going to go ahead and define this type for me. So it now understands that IR code is an enumeration data type that I can use. Then inside the main method, the very first thing I do is I set up a variable called transmit code that is just going to sit over here. Where is it going to sit at? It's going to sit on the stack. Ooh, that's a very cool one. I'll slip in on you guys. Remember, we talked about value types and reference types. Reference type, a little bit more overhead involved, right? Because it has to be allocated and created over on the heap. Then a reference has to be stored back on the stack. Well, with an enumeration, it is a value type. So we are sitting, let me just do this, and all of this is occupied. We are sitting on the stack. Okay? So I have now created transmit code, which is a variable, this guy right here, and it now knows that it will hold an IR code. Now I have this fictitious loop set up that's just doing stuff. I'm just indicating comments right now because there's no reason for us to actually create a loop and all, just to demonstrate my point. But at some point, we end up getting play information handed to us right here. So what happens? Well, up here, basically, play is what is getting stored in here. So it is an IR code play. So you could write this several ways. You could write it that way. You could just write play. You could write it as a 53. You know, it all depends on how you want to look at it without us diving too deep into technically what's happening under the hood. So that's what we've got in there at the moment, play. So to be honest with you, Logan, I'm just going to write it like this. We got play in there. That makes it easier for the example. All right. I'm sorry, guys. It's a video. You can fast forward. I want to make myself happy. We've got play in here, which is 53.
There you go.
There. I like that better. Okay, so now we're coming down to the next line, and what are we going to do? We're going to do a method call, and we are passing the argument, one argument, transmit code. So we're now passing this information, which means a copy of this information is going to be created. So at this point, all right, let's have a lot of fun. Watch this. Let's get technical. Here's what's going to happen on the stack. The stack sees that we have one parameter, this guy right here. So it says, okay, there's one parameter, and this guy is going to hold transmit code, whatever gets sent into code. So code is created. So this guy right here is code. Then on the stack, the next thing that gets pushed on there is a return address. That means we need to know where we're going to return back to, our calling point. Okay? What we have just done is we have started what is known as a new stack frame. That means we are in a new method. So we're running in a new method right now. That's kind of cool. All right, so now this information gets passed over to here. It's copied, basically, into this new variable. So we get a copy of transmit code, which is play. And I'm just drawing it out to indicate I'm showing you both the name and the data that's in it, if you will. So play 53 is over there. So play 53, or just play, is now on the stack twice. So now with that, we're going to come down here and we're just going to simply use it. We're going to write it out. So we first write out the code. So this means write out play. So transmission action is play. That's play, like such. And then the next line is going to be, let's go ahead and cast it so we get the 53 out. So transmitting IR code 53. Now we hit the end of the method. So this stack frame right here is going to basically unwind. What does that mean? Well, we're going to set our execution pointer back to where our return address says we need to go. So now it knows that we need to come back into execution somewhere up on the stack up here. So this was the last thing we were dealing with on the stack. In most simplistic forms, an execution pointer points us back to right there. How do you like that, Logan? I just kind of snuck one in on him.
Very nice.
Okay, so, but that means since the stack was unwound, now you can actually see how scope is really working. Remember how we said variables in one method can't be seen in another? That's right, because the stack frame that existed for that particular one just got erased. It just got wiped out.
It's good that it can't be seen anymore because it's gone.
It's gone. There you go. I didn't want to really push all that on you guys during the scope lesson, but it would have been fun. Anyways, okay, that's just cool stuff. But moving back on. So now we've printed out play and we've printed out 53, and then our loop, our fictitious loop, simply just continues. And obviously, if we were writing this software for real, this would be handled a bit differently. It would just say, take whatever raw data we get and turn that into an IR code and put it in there, which I'll demonstrate that in just a second. But Logan, if we could just code this one little thing out real quick and show them that it works, that would be awesome.
Okay. Well, let's jump back into Visual Studio. And you want to just wipe this example out for?
That's perfect.
All right, we'll wipe all of the contents out. And this enum is now going to be IR code. So we have an enumeration IR code. We're going to have things like play.
Okay.
Play is going to be equal to
53.
Code 53. So we'll do comma. The next code we've got is stop, which is going to be equal to 16. Then we have rewind, which is equal to 12. And finally we have fast forward, and that is equal to 13.
All right, very nice. So now we need to go ahead and come down into our main method. And where we were creating a browser, we're no longer creating a browser. So, yeah, we can just wipe all that out. And we're going to now create an IR code. We need a variable. So, IR code. And we're going to call this variable transmit code.
So, transmit code. All right.
All right, now let's go ahead and jump down and go ahead and give me a single line comment and just say loop or loop start or whatever. It doesn't matter. All right, so loop start. Jump down next line, / and give me 3 of those just to indicate the indentation. And we'll just say get button press info or button press raw data. All right, and then jump down to the next one. And now this is where we're going to hard code it in at the moment just so that you guys can actually see this all taking place. Let's go ahead and jump over and assign transmit now. So transmit or transmit code. Go ahead and hit tab. And we're pretending this is inside a loop.
Okay, so in this pretend loop.
That's right. So transmit code, this is where we're going to initialize it, is equal to ircode.play. We'll pretend that's the data we got.
So we've got ircode.play. All right.
Okay. And then,
I knew it was going to
go up and there you go. Sweet. All right, now on the next line, let's go ahead and tell it to transmit. Now, transmit doesn't exist. We'll define it in just a second, but we'll go ahead and transmit the transmit code. All right, now what I want you to do is go ahead and, and then just say loop again, and that just indicates that this is all caught up in a loop.
All right, so end loop.
Okay, now, let's go ahead and jump down. Up. Now, go ahead and hit delete, delete. There you go.
I got you. You want to start on the...
And let's do a new static void method.
So we'll jump in below the main method. So we can define static void transmit.
There we go.
And now transmit needs to take in an IR code.
Don't worry, guys. I've already caught the problem. And code. And then go ahead and block it in. And before we do anything else, check this out. Back up here, when you actually created the
I didn't
call,
name transmit.
Yeah, just take the word code out of that.
Transmit. I got you.
He was just testing to make sure you guys caught it. Okay, so now that we've got transmit in there, let's go ahead and just do a console.writeLine.
Okay. Console, we'll tell it to write out, and then you want to write out, the first one was saying that the transmission action was something, so we'll write out, we'll start with a string, we'll say let me get the capitalizers. Transmission action is going to be,
and just the code that we got in.
So that will be code.
Okay.
So we can finish that off. Now we want to do another console, write line, and write out the transmitting IR code, or that we are transmitting IR code.
Yeah.
So transmitting IR code plus, now we want to get the numeric value held inside of that code, so we need to cast this over to an int, and we'll be casting code.
Very nice. All right, so let's run it and make sure we see transmission action play, transmitting IR code 53. Transmission action play, transmitting IR code 53. Beautiful. So our stuff is working. All right, so go ahead and close that. And then just for the heck of it, real quick, let's go ahead and come back over here to the whiteboard. Now, obviously, what is being handed to us is not going to be ircode.play. So the processor, the little bitty teeny processor inside the remote control is going to hand us some raw data. It's going to actually hand us the 53. We're going to turn it into our own format where that represents play. Does that make sense, Logan?
Right, we want to, because we might not, the key press button isn't going to be in IR codes. It's going to be in numeric whatever was pressed.
That's right, so we're going to be receiving that. I just want to demonstrate real quick that we can take...
Well, yeah, just take some of the mystery out of that whole raw data thing we were talking about. How would we get some raw numbers into the enum? That's
right, so in this particular case, let's say that, I'm just going to clear some of this out real quick, that what we got in here, instead of that, was actually a 53. Well, I can't put a 53 over into transmit code because transmit code is of type IR code. But I can cast it. So I can come over here and say cast 53 using the cast operator to an IR code. So now we can get raw data and convert that over into what we need to go into transmit code. All right, let's go ahead and demonstrate this real quick, Logan, and show them that the results end up being exactly the same.
Okay, so over here where we were giving an IR code, let's wipe that out. Instead, let's cast the number 53 over. So, of course, we have to cast this to IR code, and we're casting the number 53.
Okay. There we go. And so now that we've got 53 there, and we know that 53 up inside our enumeration type definition, 53 is play. Go ahead and run it, and let's see what we get. Look at that. Transmission action, play. Transmitting IR code, 53. Hit enter. Let's prove that this is indeed working. Change it to a 12.
Okay. So let's set
which is
12.
Rewind. So let's go ahead and run it. Just by putting that 12 in there, it knows that the transmission action is rewind and that we're now going to transmit out the code 12. Beautiful, beautiful stuff. All right, go ahead and hit enter or close. Let's jump back over to the whiteboard. There is an issue with doing this. What if we got 533 sent back? 533 is not up here. This is not an error. This will not break anything in regards to the simple functionality of this 53 being assigned over into transmit code, okay? But it very well may break your logic later on in your own code because you're using an enumeration because you're relying on these grouped names.
Right, if you were relying on getting an IR code and that IR code being one of the 4, play, stop, rewind, or fast forward, then you'd have a problem because you'd suddenly have a case where you'd fall through all of your checks and nothing would happen.
That's right. So there wouldn't be a play, a stop, a rewind. There wouldn't be anything representing 533. So you would need to validate that. Now check this out. Start thinking about how you would do that because in the next video we've got our knowledge review. And that is going to be one of the knowledge review questions. I'm going to give you a little bit more information, of course, when we define what the problem is that you have to, try coding out in the knowledge review. But then we're going to turn around and we're going to design it ourselves. But the bottom line is this. You would want to validate this transmit code. So once you put a cast it 533, cast it over to an IR code into transmit code, you would want to validate transmit code to make sure that it is one of your set types, okay? That's very important. So let's see, is there anything else I want to add with this example here? Logan, can you think of anything?
Not really.
Okay, so let's go ahead and move on and look at one last place with enums where we're going to be using it in this very volume. When we create the game precision, we're going to use it for game states. All right, so let's go ahead and I'm trying to think anything else. I mean, we've showed numbers.
Well, just to completely clarify one thing, just in case you're wondering about, we were assigning values into an enum, because before we had said, of course, that an enum is a list of related constants.
Right.
So how are we setting something? Well, we're not setting or changing the enum itself.
No, the enum internals are not changing.
When we define a variable of type whatever enum we had, technically, if you want to look at it at a deeper level, it's almost like we just have another number defined, a number of whatever type our enum was using. So it's like that IR code, transmit code, is almost like having an integer transmit code. Right. The difference is that it knows what kind of enum it's supposed to be, and generally you use it along with IR code and just use one of the values inside of IR code. But it is possible to set that transmit code to something not found in the IR code enum, and that's where we get back to the whole checking issue.
Exactly. Very cool. All right, so let's go ahead and bring up another piece of paper. Well, digital piece of paper anyways. So we're now going to take a look at, well, let's go ahead and do it with as much fun as that is, red ink. Let's go ahead and come up here and turn off our tools and hide this. We're now going to use enums to represent game states. Very common practice. Basically, when a game is running, you could say that the game is in a particular state. We all know that in a game, generally there's a game loop, okay? And during that loop, every time we loop through it, that's where we're doing things like updating all the logic in the game itself. Everything is being calculated and moved or whatever, and then we're drawing the result of all of that, right? And it just keeps on going. But what if we happen to be at a menu screen? Do we want to calculate enemies running around if we're sitting at a menu screen waiting to, play a game? Or let's say you just died. We don't want to calculate, perhaps your player movement or anything because you're dead. You can't. That's not going to happen. Or what if your level just changed, right? So there's these different states that your game can be in, and an enumeration is a fantastic data type that we can use for representing game states. So let's go ahead and give a real quick example of this. And the reason I'm throwing this in here, even though we're not doing anything fancy with the definition itself, I just wanted you to see how we can use a switch case statement or a switch statement for working with enumerations. So just one more really cool thing to see. So let's pretend that we had defined the following. Enum game state. And we said that game state could be, we could be at the title screen. We could possibly be playing the game. We could be in the middle of a level change. We could be, well, how about dead? Died. Or, I should have wrote dead, I wrote died. Or how about the game's over? Okay, and then let's go ahead and close that off. So here we are. We have defined game states that can exist. We can easily come in here and add another state. Just simply continue following the rules there. Put a comma after game over and add a new state if you want to. All right, now let's go ahead and pretend. So this right here, again, we're just kind of stipulating because I don't want to have to draw everything out. That's defined in its appropriate place. Now we're down inside our update routine. So this is inside the loop that's running over and over and over in our game. So our game loop. We can now have a basically we have a variable that exists, and let's go ahead and just represent this. This is outside of the loop. We came in here and we had a game state variable that's called game state. Notice the use of casing here, lowercase g for my variable name. All right, now I can come down here and I can, just to give this demonstration some momentum, I could say game state equals, now my capital G, game state, so my identifier dot, and let's say we're playing the game. Playing Terminator. Alright, so now this is set somewhere else in code, right? Now we're in our giant loop. So this is where we'll just continue looping over and over and over. So in here I can now say switch based on game state. And then let's go ahead and put the block in place. And I'm not going to write everything out here, but I just want to give you an example. I could say case game state. Here's the whole reason for drawing this out. Dot title screen colon. Notice I use the identifier name, this guy back here. The same thing I do when I'm actually assigning information into the variable of that type. Dot and what constant within it that I'm going to look at. So switch game state case, it is this right here, game state dot title screen. Now I can do stuff. I can say write out that we are in blah blah blah, and then let's break. Okay, and then come down with case, and then I can continue doing this all the way down, and I'll put the closing curly brace for my switch statement. So basically I can go through here in the loop, and always each iteration to the game I could say what state is the game currently in. Oh, we're at a title screen. Okay, well, the things we need to do while at a title screen may be, well, draw the title screen. So we just redraw the title screen, okay? In regards to update, what would we do? Well, maybe we've got these little things bouncing around the screen while the title screen's up, right? Just for some sort of visual effect. All right, we'll update those guys. We don't need to worry about game logic and stuff like that because we're not in that state.
Or even better, what if you could get some really weird behavior? Like, let's say you didn't have these states set up. So you're at the title screen and you saw the title screen. Mm-hmm. But enemies and players were running around the background. So all of a sudden you're staring at the title screen and the game loses itself. It goes to the game over screen because the background game that was still playing finished.
So your example is if you had no states whatsoever. We just bunched it all up in update.
It's like you watch the title screen and then just watch the game end with no interaction.
Okay, my head hurt and I don't know what but then it would all happen again. Because it would be re-looping through all that constantly.
Right.
So yeah, you'd be looking at a very interesting fireworks display from your own game. How cool is that? But by doing this, we can break the game up into states. And depending on what state the game is in, we can execute specific code for that state. So if we were in down here, the playing, well, now we might want to do enemy. I can write, I promise. Logic, update player, all that kind of stuff. So we would put all of that code into this particular state. So very, very handy. Logan, I'm going to have you real quick go ahead and jump over and let's create this one.
Okay. Let's jump into Visual Studio and let's just begin a whole new project.
Sounds good to me.
And again, a console app. All right, let's start with the game state, enum itself. So we've got enum game state, which is going to contain things like title screen, and I'll catch the capitalization here. We're going to have playing. We'll have level changing. I so had changed.
Yeah, level changed.
Okay, because that goes well with died and game over. All right. So let's put this to use in an example scenario. Let's set up something where just after is entering the static or the main method, let's set the game state. Or even before we do that, let's define a variable to hold a game state first off. So we want to have a game state variable called game state, lowercase game state. Then let's turn around and set the game state to be game state dot, what is it, title screen?
No, we'll just do playing.
All right. So we're going to set this off. So now we have the state of playing.
Now, since you can copy and paste here in the switch, I want you to actually code out all of these. So we'll make use of them in just a second. So go ahead and just type switch.
Okay. Let's begin our switch. This is going to be switching on game state. So I'll block in the switch, and now let's write out the first case.
Yes, case.
Let's have a case game state. Let's do the case for title screen. So we'll do colon, drop down a line.
And let's just console right line do at the title screen.
All right, so we'll write out at the title screen.
Okay.
All right.
And of course we got a break. Now just copy all that and
let's throw in an extra line. Copy all of that.
And 1, 2, 3, 4 more. Okay. So let's go ahead and just change the stuff real quick.
All right. So let's do the state for
playing.
And so
you are playing. Okay. Next one is going to be level changed. So take the
double C.
And then just put in level has changed.
Or even level is changing.
Or is changing, yeah. That works. And then, actually that works better, of course, because that's the whole idea. That's the state. All right, for this one, let's go ahead and put in died.
And you have
died, sucker. All right, next one, let's go ahead and put in game over.
Game over. And just write out
the game is over.
Game is over. Over.
Now, the first thing I'd like to point out before we run this is in this particular case, we've seen. Let me just jump back over here real quick and pull this back up. We have seen that in certain situations, we may want to come in here and assign our own numbers. Enums are notoriously used in situations where the number is technically irrelevant. Okay, it's very common to use enums for a situation of just holding a bunch of related names, and you don't care about the numbers because you're just going to be using those related names throughout your code. You'll never worry about a 0 or 1 or what's being stored inside of it. And that is exactly what we're seeing here. Basically, what Logan has just coded out, at no point did we ever check to see, is it a 0, is it a 1? We just never did that. Even when we got down into the actual switch statement itself, we still never worried with what was the number that's being stored in these particular constants. It was irrelevant to us. We were able to come in here and just say the game state dot title screen. So again, that allows us to easily come back up here to the game state and throw a new state in without messing up our code. And now we have a new state that we can put the game in to work with. And I'll demonstrate that in a second. First, Logan, let's go ahead and build and execute.
So we build. And I think I mistyped the R
in there.
And then we can build, and everything's good. Now we can run.
Okay.
Now we need a read line.
Yeah.
So we'll
after
do some
the
stuff,
switch,
jump down here below the switch where we can go console read line, and now let's see what happened.
All right, so we should be playing. You are playing. All right, so to demonstrate this works, let's go ahead and put our game state into, we died.
All right, so game state died.
And we run it. You have died. All. Okay, so we can see that this is real simple. So let's go ahead and close that. Let's come up with a new state. So, Logan, I just came to you as one of the designers and said, you're coding this part of the engine. I need you to add this state. Let's see. What would be a cool state?
How about, let's change it so that it's no longer like canon. Let's make it to where you can win the game. There's a final ending.
I like it.
So we have game over. We can have win or won or... I'll just put it as win.
Okay, win sounds good. All right, so let's run it. And you've still died. It's as simple as that. So by going in here and adding, as a matter of fact, if Logan would have put win in another place, so if he would cut that and put it between died and or wherever, anywhere else. So there it is in the middle. Just put that comma in there and take the other comma out, run it. Nothing broke. It still runs just the same. The nice thing is we now have a new state, so Logan could now go down into his loop code, down to the switch statement, and add this new case in, and add the appropriate code that needs to occur when the game is in this state.
So we could put in a case for a game state of win, where you can say, yay, you won.
Okay. And if we, did you change the actual game state itself?
Not up here. It's still
okay. So you go ahead and run it. So you still died. And now, if we test out this new state the game can be in, let's put it in a win state. Yay, you won. There you go. Enumeration, very powerful stuff. It really is. It's not hard to work with. You just got to get used to, doing the type definition thing. Not a problem. You saw how Logan had created the type definition outside of the class. This also could have been local to the class program itself if he wanted to put it inside of here. And he could have made it public. He could have made it private. We saw that we had modifiers that we could use, and they're optional, all the way back when I was talking about the basic syntax of using an enum. And anything else you want to add to this, Logan?
No, just that the key is that you get to work with everything as a textual label instead of having to work with specific values. Like you said, each of these are, of course, assigned a value automatically, but throughout this entire example, we didn't care about what the actual value was, only that each of these are unique and different from all of the others, so that we know that if we're in the playing state, we're not in any of these other states.
Exactly.
So the key is that it makes the code a lot easier to use and read. If you come back into this code years later and you look at this state, well, it's obvious what's happening in the state, because we have a state playing. Well, okay, we know what that is. Even in the previous example, in the remote code example, what if you were handed that code and it was now your job to maintain it, you having not written it? Even though you don't know what those numeric codes really mean, the rest of the code uses that enum. Right. So you don't know what 53 really means, but you see later, all right, playing. Well, I know what to do if we're playing. Exactly. So you could maintain that code even though you don't know what the values mean.
That's right. All right, very good. Well, I think that's everything we need to talk about with this introduction to enumerations. So that is going to wrap up this video. Thanks a lot, guys.